The human body has more than 600 skeletal muscles. That means that we have more than 600 muscles under our control and coordination at any given moment, and almost none of these muscles work alone. They're always going to be working in pairs. So just for example, taking a step is going to require as many as 200 muscles. And so at the very least, these muscles work, if not in a group, in pairs. And so there are going to be a couple of pairs we're going to talk about. Synergistic muscles are muscles that must contract at the same time to cause movement. Antagonistic muscles, on the other hand, are going to be movement that is produced when one muscle of the pair contracts and the other relaxes. So a great example of this would be your bicep muscle and your tricep muscle of the upper arm. When your bicep is contracted, your tricep is relaxed. When your tricep is contracted, your bicep is relaxed. Oh, there we go. Example, the bicep muscles and the triceps of the upper arm. And here's a great example of that. The bicep contracts and pulls the forearm up, flexing the arm. The relaxed tricep is then stretched. The triceps contract to pull the force of the arm downward, extending the arm, and the biceps relax and are stretched. And so that's sort of how the antagonistic muscle pairs work. So here is just a great diagram of some of the major muscle groups of the body. So I would spend just a little bit of time with figure 6.2. I'm not going to have you memorize all of our major muscles, but if you are going on to take anatomy and physiology, this is a great figure to help review and help give you some info on the major muscle groups. So here's some terminology that I would like you to take away from this course concerning muscles. In order for the muscular system to have motor control over the rest of the body, it has to be attached to our inner scaffolding or our skeletal system. And so there are a few things that I want you to know. Most of the major muscles that we use for locomotion, manipulation, and other voluntary movements are going to be attached to bone. The attachment to bone is going to be done through a tendon. A tendon is going to be a band of connected tissue that attaches muscle to bone. Students often get tendons and ligaments confused. If you remember from our last chapter, what do ligaments attach? Usually they're attaching antagonistic bones on opposite sides of a joint, and they're helping to hold that joint in place or help to direct the movement at that joint. So ligaments attach bone to bone, tendons attach muscle to bone. An example of homeostatic imbalance would be tendinitis. Tendinitis is a condition of having an inflamed tendon, usually caused by overuse, misuse, or age. And the healing tends to be very slow because tendons have a very poor blood supply. They are a thick fibrous tissue. They are not richly embedded with a lot of blood vessels. So the most effective treatment for tendinitis is going to be rest. Another term I would like you to know is the origin of the muscle. The origin of the muscle is going to be the end of the bone that remains relatively stationary during muscle movement. So, for example, if your bicep is going to be responsible for pulling your forearm up towards your upper arm, then the point of attachment on the upper arm is going to be the origin. The insertion of a muscle is going to be the end that's attached to the bone that moves. And so in the case of your bicep, the origin is attached to your upper arm, and the insertion point would be attached to your lower arm or your forearm. A muscle pull is also called a muscle strain or tear, and it can be caused by the overstretching that damages either the muscle or the tendon. And again, the treatment is going to be ice to reduce swelling and keeping that muscle sort of stretched out to help it relax and heal up. So that's just another example of a homeostatic imbalance that may affect this particular system and or group.